Hi, I'm Steve Blume, and I'm the author of Electric Power System Basics for the Non-Electrical Professional, 3rd edition. And I kind of wanted to spend a few minutes to kind of explain to you what is actually involved or included in this book. Start out with generation, transmission, distribution, control, protection, telecommunications, and electrical safety. All of those major concepts are in this book, but it's explained in simple to understand terms, electrical concepts, all the way down to the very fundamental when it comes down to physical laws, like gravity being a physical law. There's a physical law that's associated with current and one associated with voltage. And understanding that just the two physical laws will explain how the entire electric power system works. So we start out with the fundamentals, terminology, get everything all understood. What is electricity, how it works, how we conserve load and generate, and then also include items with batteries and DC and enhancements, which is quite a bit going on. DC transmission, DC batteries, just different areas are changing, but putting it all together, talking about interconnected power systems, how different utilities in different states and different power pools and different independent system operators, how all of those different independent systems connect together and operate together to build our giant mega electric power grid system and provide reliable service. Once we have a good handle on how the power system works in very simple, basic, general terms where you feel comfortable with what this big electric power interconnected grid operates, over the years it's been that way for a long time. Now the book starts talking about the transitioning digital power grid. So now we're going to be talking about system operators having vision of wide area monitoring with synchrophasers and other technologies, distribution automation to help provide service reliability, getting into cybersecurity enhancements. These are some of the areas that our power grid is transitioning into a more digital concept. We're bringing in the data centers and all the other areas of load growth, for example, electric vehicles, how that is affecting our grids, how our renewable energy is impacting our grids with solar systems providing energy during the day. Well, what happens in the evening when the sun goes down and we end up with all this need, all this demand, and we have batteries with inverter-based resources providing energy for the 4-hour period after the sun goes down until we get past our peak demand. These things and how wind generation affects and other renewable resources, how all of these grid modernizing and our energy resources and demand systems are changing over the years, and what does it look like in the future? How are we enhancing, keeping up with all this change? These areas are all covered in this book in simple to understand terms. It's loaded with pictures, it's loaded with graphs, it's going through, there's a lot of information, a lot of pictures kind of showing what's going on. All of this information is in this book. And for example, some of the areas that are covered that are very helpful would be generation balance. We're moving from spinning inertia, large generators that have all that mass that's spinning. And when there's a fault or a problem, a short circuit on the power grid, that big mass is still turning. It helps push through those faults, allows the system protection schemes to operate and trip circuit breakers. All of that is explained in this book, but we're transitioning more towards inverter-based resources, which are basically taking DC systems and converting them to AC, and you don't have that spinning inertia. Battery systems, solar, wind generation, those are all providing energy, but they don't have that spinning inertia. The industry changing to voltage and frequency ride-through capability. In other words, don't trip the solar system quite so early. Don't trip the wind quite so early. Hang on, ride through some of the low voltage and low frequencies to provide the same effect as spinning as inertia. So these industry changes, and all this described in here, how we're using variable generation with variable demand and making a stable, solid frequency system out of those moving parts. That's explained here. Then we cover in here some of the other areas like wildfire mitigation techniques. What are the areas that in distribution, transmission, where there are techniques being implemented to identify trip lines quicker, faster, before ignitions can occur. Trees coming in contact with conductors, understanding some of those characteristics and information signatures that are identified with protective relays so that these lines can be tripped faster to help avoid wildfires, for example, or some of the growth in electric vehicles. We talk about, the charging systems that, have fast rate and slow rate. How long does it take to charge up an electric vehicle? What's the future with all this charging and battery storage and data centers, the amount of demand that these data centers that's enhancing our AI and all these other modernizing things. This new load and the growth, how is that impacting the system? What is the system doing to be able to accommodate those kind of changes? That's all explained here in this book. And I hope it's something that if you read and get through to the end, you'll be able to have a good handle on how our system is maintaining reliability, it's being grid modernized, it's transitioning, and yet there's so much more to come. And this book has so much information in it that if you need some help, if you have a group of people and you want to have some training or some online or instructor-led training, I can arrange to have that provided for you, where you can have this presented to you in a class. Also consulting services if you need some help with your particular situation, how it can impact the grid or how the grid can impact what you're trying to achieve. And if you want any more information on how this book and instruction or consulting services can help you, please feel free to contact me on my website, on my LinkedIn page, or through the information provided here in this short video. So with that, good luck to you. I hope this is something that you benefit from, and it is geared towards the non-electrical professional. Have a great day.